Good afternoon, students. Am I audible to you? Am I audible? Okay, fine. Students, very good afternoon and welcome to the lecture on classification. So before going to this classification, I want to clear with you people. Uh, are you clear with the last class? Are you clear with the last class, or shall I go with the repetition of the last class? Kindly let me know. If you are clear, I'll move on to the classification. Okay, kindly hope you people are clear with the last class. A priori algorithm, association rule followed by a priori algorithm. So in today's class, I am going to cover the concept called, okay, in today's class, I am going to cover the concept called as classification. So before going to this classification, uh, what comes into your mind when you come across this term called as classification? Classification is the process of dividing the data sets into different categories or groups by adding labels. This is the general definition of the classification, but let me give you a good example for this one. Let me give you a good example about this classification. Uh, Hope everyone will be making use of the Gmail. Okay, mailing, whether it might be Gmail, Google Mail, Yahoo Mail, Rediff, or blah blah blah, any type of mail ID. So in the process of this one, you'll have the different sort of options which were given: inbox, outbox, sent, drafts, spam, trash. Okay, so here the classification is the thing. Classification is nothing but one of the algorithm. Okay, uh, means the classification concept is divided basing on lot of algorithms. So by making use of these algorithms, the classification will be done. And in this process, when you receive a mail into your mail ID, then here the actual classification will start. Whether this mail should be moved on to inbox or it should be moved to the spam. Okay, basing on certain criteria. So that criteria will be known with the help of this classification. Okay, so few will think that your mail moves into inbox, and few will think the mail is moving into spam. Okay, we don't know on what basis this is being moved. Okay, so this is being moved basing on lot of data sets and algorithms which will work across it, where the data is being moved into. Okay, so for few of them the data moves into inbox, and for few of them the data will move into spam. Just I'm increasing my voice level. Okay, so which is nothing but the classification is the process of dividing the data sets into different categories or groups by adding label. So here we gonna add label for the data sets, and we'll say that these data sets belong to this particular classification. Just like the mail what we receive, uh, certain mails what we receive is going into our inbox, and we have created a label there called as inbox, and few will move on to spam. The spam label is already there, and there we have an option of making some labels, right? If some personal information need to be stored, we'll create a label called as personal, and certain mails will be moved on to drafts. When we type something and we haven't posted it, then certain things will be saved under drafts. So this is how the classification will be done. Okay, so guys, do remember the definition of the classification, which is nothing but the process of dividing the data sets into different categories or groups by adding label. And one note here is that it adds the data point to a particular labeled group on the basis of some condition, right? So you see here in the note, I have given something called as the labeled group on some particular condition. So here the data is going to be labeled into a particular group basing on some conditions. So on what basis we have conditions? What is this some condition here? We are going to talk about these things. Okay. So let us have a brief description about the classification. What are the different types of classification techniques exist? And today we are going to learn about, in brief, about the different sort of classification techniques, followed by uh, a decision tree technique in detail. Let us move on to the next slide. So here the classification is divided into certain things. So we have four different types of classification techniques. So guys, do remember these. These are the four important classification techniques. Since yesterday's lectures, we keep on listening about the clustering and the clustering algorithm. Okay, and from today class onwards, we will be concentrating on the different types of classification. Okay, so the classification is, I forgot to convey you one thing. The classification is nothing but it is the supervised learning technique, and the clustering is unsupervised learning technique. What we have learned till yesterday, all the techniques belongs to unsupervised learning, whereas this classification is the supervised learning. So the difference between the supervised learning and unsupervised learning, hope we have discussed already about this one, where the supervised learning uh, will work or will function in the context of some prior or predetermined training or predetermined conditions, whereas in the unsupervised learning will never come across any predefined conditions or any sort of training techniques will exist there. So that is the difference between the classification and clustering. So the types of classifications what we have here are the decision tree, the random forest, navy Bayes, and k nearest neighbor. KNN stands for the k nearest neighbor. Whereas in the clustering also we have gone through the types of clustering, starting from the partition clustering technique, where we have come across the k-means, the hierarchical clustering technique. Next we have come across the decision DB scan. Next, we have come across the grid-based technique. Then we have learned about the a priori algorithm. Okay, so in the types of classifications, we have the first one, the decision tree, followed by the random forest technique, next the naive Bayes, and followed by the k nearest neighbor, what we are going to study. Okay, so let us start with our first technique, which is called as the decision tree. So let us start with a good example about this decision tree before going into the concept. Anyhow, I have given an example where you can look onto the screen, but in general, let us go with some more generalized example. Hope everyone will be making use of the mobile, and whenever you want to talk to any customer service representative, or whenever you go with the customer care, uh, whether it might belonging to the same mobile company customer care or any banking customer care, then he'll be asking you to dial the customer care number. And when you pick your phone and start dialing the customer care number, then there he is going to give the options for you. In order to continue in English, you have to go to one option. In Hindi, another option. In Telugu, another option. Like this, he'll talk about multiple languages. So from that one, the decision is ours, where you need to go, whether you want to go with the English conversation, Telugu, Hindi. So we'll take a decision there and we'll click on one. So once we click on one, then we'll be routing to some other place, right? Suppose if you talk about the banking structure, right? So there he'll be asking whether if you want to know information about your account, then click on something. And if you want to know about the balance or something, some other option, if you want to speak to customer service executive, then he'll be giving some other option like this. So he'll be giving a set of picking options, and we keep on taking the decision where we want to go actually, whether we want to go to know some balance of our account, or we want to know the credit card information, or finally whether we want to talk to the customer service executive. So when the term of the customer service executive appears, means like this we'll keep on moving, right? So this is nothing but the process of taking the decision by us, whether we want to talk to the customer representative or want to know the credit card information, etc., etc. So the decision purely depends on us. Okay. So here, let us look at another example. What I have given here. I want to go to a restaurant, or I want to have a hamburger. Okay. So it is up to me what decision I need to take. First, I'll start with the root node. The root node, what I have here is, am I, sorry, the root node, what I have here is, am I hungry? If I am not hungry, then certainly I'll go to sleep. Okay. If I am no for this one, I go to sleep. If I am yes, I am hungry, then I'll check out, have I, right? So how much amount I have, whether I have $25 or less. If I don't have $25, then I'll go for a small to buy a hamburger. I'll have it and I'll go to sleep. Or as if I have $25, then I'll go to a restaurant. And in turn, here also you can generate some trees, whether you will go to what kind of restaurants, whether you go for Indian restaurant or Italian restaurant. If you go to this one, so what you will prefer, right? Like this, the tree keeps on discovering depending on the requirement of the user. Remember here, it depends on the requirement of the user. Just like how you have made a phone call to the customer service executive in order to know the information about your banking application, right? Whether you want to go with your debit information, your credit information, credit card information, or you want to know about any insurance policies across your account, or you want to know the offers across your account, or you want to talk to a customer service executive. So it all depends on the information what you need, the data what you need here. Okay. So according to that, the data is going to be segregated, the decisions will be taken, and you are going to end up at a particular point where the maximum information gain for you happens. Why all we are doing this one? The classification is basically we are doing in order to gain the information, because once you gain some information, then you can come to a conclusion where you can easily construct a particular tree which is required for uh, exploring the thing. Okay, so this is a simple general example. Hope you have understood. So what is the actual definition of this decision tree? Okay, so it is the graphical representation of all the possible solution to a decision. So remember this, graphical representation of all the possible solution to a decision. So why we are calling it as a tree? Just as we have taken an example, so it is will be exploring all the possible options. That's what, when you dial to a customer care executive, he is going to give you all the possible solutions, whether you want to go for debit, the credit, insurance, or you want to know about the loan, you want to know about something, blah, 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 or the given data is not sufficient and I want to talk to a customer service executive, then the final option will be given, right? Means all the possible options are going to be explored for you, and it is the responsibility of yours to take the decision whether you want to go in which particular direction. Okay, next. Decisions are based on some conditions, right? So for this decision tree, the decisions are purely based on some particular conditions. So what are those conditions? The conditions are left for you itself, depending on the application and depending on the problem you have. You are going to take some decisions basing on the conditions, and decisions made can be easily explained. So the decisions what you have taken or what you're going to take, they should be easily explained. They should be understandable. That is what, if you look into the example, what I have taken here at the bottom, right? So it is easily been understandable, and otherwise when you dial to a customer service representative, you should be in a position to explain what you actually want and where you actually want to go. Okay, so remember that the decision tree, the graphical representation of all the possible solutions to a particular decision. So this is about in brief about the decision tree. And next what we have is the random forest algorithm we are going to look into. So this is the random forest algorithm what we are looking into. The random forest algorithm builds multiple decision trees and measures them together. So what is the need of this? Just like a simple known thing that we are calling it as a random forest. Why we are calling it as a random forest? Because randomly we are picking certain data and we are making some decisions and we are merging them. And the forest, the name the forest is being mentioned. If it is a tree, then we can have some decision. And why we are calling it as a forest? Because the number of decision trees are merging here, and uh, as we know that if more than a limited number of trees exist in a particular location, then we're going to call it as a forest. This looks like a forest. Okay, so uh, the multiple decision trees what we are having are going to be merged to give more fruitful information, or we can say the information can be explored very fast, right? That's why here multiple decision trees are going to be merged to have the fast output. Okay, and next, more accurate and stable prediction, right? So the why we are merging the decision trees, in order to have more accuracy across our this one, and to have the stable prediction, right? So the prediction, in the sense, once again here will come across the concept of the probability. Okay, so next, the random decision forest correct for decision trees habit of overfitting to their training set. Okay, the random decision forest correct for decision trees habit of overfitting to their training set. Means here for the decision trees, the random forest means overtraining will happen, right? Because here the number of decision trees are going to be combined in order to give the outcome based on the measure, measurement. Next, trained with the bagging method. So bagging, what do you mean by bagging here? Bagging is nothing but holding some data at the back, so that the data is going to be supported for this one. Just like the piggybacking technique what you have in your computer network. So if you look into these two different uh, examples what have been mentioned in the example A and in the B, how the data set what is being available here, or the training set, can be classified into. The training set is been classified into two important things. This is the sub training set one, and this is another sub training set one. And once the data from this is being explored, then here we have constructed a decision tree. It is another one, right? So here we have constructed the two different decision trees, and these decision trees can be further be divided into sub set of these decision trees, where all these decision trees once again are going to be combined to give the random forest technique, right? So this is how the data is being segregated into. This is one decision tree what we have, and this decision tree, let us see, this is one, and the same decision tree is one here, which is further been classified into till we reach the node. Okay. So this is about the random forest. So all these decision trees are combined like this, where we can have the random forest technique. So we are going to merge all the decision trees in order to get multiple decision trees and merge them together to give the output. So we can say the outcome of the random forest can be the merging of all the decision trees, we can say here. And next is the naive based classifier, we can say. Okay, naive Bayes. So classification technique based on Bayes theorem, right? The name came for this one based on the Bayes theorem. So assume that the presence of a particular feature in a class unrelated to the presence of any other feature. So presence of particular feature in a class is unrelated to the presence of any other feature. So let us have understand the meaning of this one. Okay, so if you look into the example given here, is P disease 0.10 and P disease 0.90, means the probability or the prediction of the disease, the prediction of occurrence of the disease is this one, and the prediction of non-occurrence of the disease is this one. That's why the bar is being represented. Bar represents the non-occurrence. If you look here over the disease, you have a bar represented here. This is the bar what is being represented. This represents the non-occurrence of the disease, and this is the probability of occurrence of the disease. So the probability of the occurrence of the disease is 0.10, and the probability of non-occurrence of the disease is 0.90. So if you look here, the probability means here it is being divided into, this is the probability of non-occurrence, occurrence of the disease, occurrence, and this is the non-occurrence, and this is nothing but non-occurrence. Okay, so in the probability of occurrence of a disease, right? So what is the value, the probability of occurrence of the disease? What positive means the positive cases that the disease is going to occur is 0.80%. And you see here in the probability of occurrence of a disease, here the tree is divided in this fashion. It is divided into two things. This is one and this is another. And when we are talking about this one, the possibility of occurrence of a disease, the positivity is 0.80. And here one more thing comes. This is the occurrence and this is the non-occurrence, right? The tree represents this is occurrence and this is non-occurrence, and the positive that the occurrence of a disease is negative. Negative in the sense the disease, the chances of occurring of the disease is very less. Which particular disease? Okay, it is 0.20, means already we are saying that here this case is this entire case is This is occurrence 1, and this entire thing is non-occurrence, non-chance, the chances of occurring of disease. Okay, so in this one, 0.80 supports that already the disease is there, and which is nothing but 0.80%. And here, as we are saying that this entire branch talks about the occurrence of a disease, here it says that in the occurrence of a disease, where is the negativity, the false? Saying already we said this entire thing is talking about the disease uh, occurrence, and in this one we have the negativity saying that there is no occurrence of a disease. So we are calling it as false negative. The chances of occurrence of a disease. So the chances of occurrence of a disease here we have 0.8%, and in the chances of not occurrence of a disease, once having a disease, we are talking about the chances of occurrence of another disease, which is nothing but the false negative here. That's why we are saying, why we are saying the negative here. In the similar way here, it is non-occurrence uh, of a disease, which is nothing but 0.10%, and we are calling it as false negative, and the chances of occurrence, non-occurrence of a disease is 0.90. But we have 0.10 where there is a chances of occurrence of a disease, and we are calling it as the false positive. We are calling it as a false positive because we are into the non-occurrence branch, and we are talking about the positivity. That's why we are calling it as false positive. That's why we have said here false negative, because here we are in the occurrence of a disease, and we are saying negative. Negative talks about there is no chances of disease, which is nothing but false negative. Why we are saying false negative? We are in the occurrence of a disease. Here it is non-occurrence of a disease. Hope you have understood this one clear. If you have any doubt, kindly let me know. I am going to explain you this one again. Okay, don't get confused here in the naive Bayes algorithm, which is nothing but the classification technique based on the Bayes theorem. Assumes that the presence of particular feature in a class unrelated to the presence or any other feature. So this is about the naive Bayes, and the last algorithm what we have is the k nearest neighbor. So what does this k nearest neighbor say? Right, stores all the available cases and classifies new cases based on similarity measure. Hope you have hope you remember this term called as the similarity measure. Right, the number of objects which look similar, where in the clustering we have made use of measuring the similarity based on the Euclidean distance, squared Euclidean, Manhattan, and cosine distance, cosine measures. Okay, so stores all the available cases and classifies new case based on similarity measure. The KNN algorithm is the nearest neighbor we wish to take vote form, right? So what is this vote form? Let us look into the example what is being given here. So hope you see the three different images what were given. You can easily understand if you here if you take this entire image where the total image is considered as 1 because it is not being divided into any sort of thing. Means the information what or the data given is not being classified. But if you look into this one, the second figure k equal to 3, it is being classified into uh, 3 things, right? So if you look here, we have 5 different colors which have been given. So they are being classified into 3 things. These two being 1, and this being the second one, and this being the 3. The k is being classified into. And if you look into k equal to 5, this one has 1, 3, 4, and 5. right? This is how the k nearest neighbor is going to be uh, classified into basing on the data inputs given. That is what here stores all the available cases. The first case is that all the data objects are into one classification. Next, they are divided into three cases. They are divided into five different cases. Okay, this is how the k nearest neighbor classified. Okay. So now this is about the brief description about different sort of classifications where we have started the first one with the decision tree, followed by the random forest method, next followed by naive Bayes, and the last one is the k nearest neighbor. So we are going to study about these four different classification techniques in detail in the coming slides. So today we are going to talk about the decision tree, and hope we will complete this decision tree technique today. So what is this decision tree? A decision tree is a graphical representation of all the possible solutions to a decision based on certain conditions. Okay, we have seen this definition already in our earlier slides, but once again let us repeat this one. A decision tree is a graphical representation of all the possible solutions to a decision based on certain conditions. So let us see an example for that one where we can understand this one with this particular example. So here, let's start with the example. Decision tree. Should I accept a new job offer? Is the place where I stood, right? So I'm going to make, this is a decision tree. From this one, I deduce my decision. So let me start here, where I'm going to start here with the root node. The root node is salary at least $50,000, right? In order to accept, should I accept a new job offer? If I need to accept my new job offer, I need to have a salary at least $50,000, right? That is what where we have started with the root node. Okay, and this is place where we gonna take decisions. Okay, where we can say it as a decision node. Okay, and salary at least $50,000. If no, if my salary is not uh, less than 50,000, okay, then I'm going to decline this offer. I'm not going to move any further, and I may in search of some other thing. Leave it. Like suppose if the salary is 50,000, my decision means the offer given is meeting my decision or the criteria, then yes, I am going to take up, right? So after accepting the $50, my one more constraint or condition is that commute more than 1 hour. Whether if the job offer what I have got, if it is paying me $50,000 and I need to make a travel of 1 hour in order to attend this job, my another constraint is that commute. Commute means travel more than 1 hour, right? If it is more than 1 hour, as if it is more than 1 hour travel I have, once again I am going to decline this offer. If it is not more than 1 hour, means no, the condition is no, then offer free coffee, whether this particular uh, job or company is going to offer me a free coffee all the time. If it is offering the free offer, then yes, I am going to accept the offer. If it is not offering me, then I am going to decline this one once again. So where I have left with the leaf node. This is one leaf node, this is another leaf node, this is another leaf node, and this is another leaf node where I cannot traverse this particular tree anymore at all, right? So this is, as you people know, that the leaf is the smallest part of the tree which cannot be divided any further. Just like you people have the tokens in your compiler design or in any of your programming languages. So token is the smallest element or the symbol which cannot be divided any further. Okay, so this is about the decision tree example. Hope you have understood this one. So this has given the good insight for you. You see, a decision, let us once again understand this particular definition. Decision tree is a graphical representation. So this is graphically represented of all the possible solutions to a decision based on certain conditions. You see, certain conditions. Here, this one is one condition, this is another condition, and this is another condition. So it is, the decision is tree is not based only on one condition. It is based on multiple conditions. That's why we are calling it as based on certain conditions. We are not mentioning how many, whether it is 3, 2, 1, 4, 5. We are not mentioning any in what is the count of the number of conditions. It is only certain number of conditions, because this certain number will vary from problem to problem, application to application, requirement to the requirement, and it varies from data set to data set. The more familiar thing what we need to talk here is the conditions will change basing on the data set to data set. And one more important thing I want to mention you here is that we have the 4 different classification algorithms what we are looking into. Uh, each and every algorithm has its own prominence and its own importance. We cannot say that the naive basis is uh, the superior to random forest, or it is being superior to the decision tree algorithm, because when we have a particular data set according to a given problem, we are going to apply all the 4 classification techniques, and out of all these 4 classification techniques, we are going to look into the outcome of that one, and whichever gives uh, the good support to our problem, we are going to consider that particular algorithm for our problem or the data set. Not that as I have considered this naive base as the good algorithm for my problem, the remaining 3 are uh, useless. There is no meaning in calling, because for your given data set, naive base will suit. For some other data set, some other algorithm might set, right? Like this, here we are going to explore all the 4 given classification algorithms, and we are gonna verify that one to check which particular algorithm will fit for our given data set. Okay, hope you have understood this particular example for the decision tree. Let us move and look into some more examples. So this is the decision tree, and understanding a decision tree, how we are going to understand this particular decision tree. So we have a data set which looks like I have the 4 different 3 different attributes for this one. One being the color, the other being the diameter, and the other one being the label. Okay, so I have 3. One is the green color, and the diameter of this one is 3, and the color of this particular label is mango, and I have a color called as yellow. The diameter of this one is 3, and I am mentioning that particular label as the mango. Means we can say either I have a mango fruit which has the diameter of 3, which is of yellow color, or I have a mango fruit with the diameter of 3 with the color of green. I have a grape with the diameter of 1, and the color of the grape is in red. And the same, the grape with diameter 1 and of red color. The lemon I have with the diameter of 3 and the color of yellow, right? You do understand understood, I hope, this example. Uh, we haven't completed with this example, but I'm showing you the data set, how the data set will generally exist. Let us look into the next one. So I have the green three mangoes, and how I'm going to take the decision I have given. So my decision is that I want to have a fruit. I want to look into any sort of fruit or something with the diameter more than 3. So here uh, the decision is this one. Is diameter greater than equal to 3 is my first decision or condition I am going to look into. So whichever satisfying will come this side, and whichever not satisfying will come this side. So if you look into the given table with the diameter greater than or equal to 3, I have 1, 2, and 3. I have the mango with the diameter of 3 in green color, the lemon with the diameter of 3 in yellow color, the mango with the diameter of 3 in yellow color. So I have arranged those 3 things here because it is falling in the true case. And the next case is the false case. If this condition is not satisfying, then it will move into the false case where uh, the diameter less than 3, which are not satisfying this criteria. The one is the grape and the another is under grape. So these are the 2 things, right? So this is how I have taken the decision. Okay. And if you move, if you want to move further more into this example, we have something, because we have not left out here itself, because the decisions, depending on the number of decisions what we have, we're gonna construct the tree till we reach the leaf node. Okay, so here uh, till this is the last case where we have solved, and the next decision I have attached here. I have one more constraint saying that I want to have the fruit or anything with the diameter greater than or equal to 3, but my constraint is that the color should be in yellow. I want the fruit only with the color of yellow. So from this one, I have the 2 different fruits which are available with the Greek, right? Even though we have this one with the diameter of the 3, it is not meeting the color criteria because this is green and what we are looking is yellow. So only 2 things will fall here, which are nothing but the mango and the lemon, and the other one will come here, which is nothing but the green mango. Okay, with the diameter of 3. And if we further classify this one, we'll reach the leaf node. Okay, where the things will come up. Okay, so this is about. Okay, so now is the color green? If the color is green, right, uh, then the green color things will come here. The green color will satisfy and fall under this category, otherwise it will fall, right? Is the color green? So these are my 3 different conditions. Color green, diameter greater than or equal to 3, is the color yellow. So according to my these things, the classification will done, the decision will be taken, and it will be divided into this. Okay, so green, it is true. So I have a mango with the color of green. The other 2 are falling into this one. Okay, so this is a general example. The next one is the decision tree terminology, where you need to concentrate here, where any tree you see where it will start, the tree will start at the root. So I'm going to talk about the root now. The root node. What is this root node? The root node is, it represents the entire population or sample, and this further gets divided into 2 or more homogeneous sets. 2 or more homogeneous set. This is called as the root node. The root node is, it represents the entire population or sample. Entire population in the sense whatever exists on that particular root, whether it might be the branches, leaves, or anything, blah blah blah. Okay, entire population or sample, and this further gets divided into two or more homogeneous sets. It is going to divide into. The next one is the leaf node. The leaf node is nothing but the node cannot be further segregated into further nodes. Means it cannot be divided into further nodes, right? Suppose if you see, this is one of the node which is being divided into, and suppose this is the leaf node, this is another leaf node where we cannot divide this one any further, which is nothing but the leaf node. The number of examples what we have seen. So node cannot be further segregated into further nodes, which is nothing but the leaf node. Next, splitting. Splitting is dividing the root node or subnode into different parts on the basis of some condition, right? Splitting is dividing the root node, or we can say the subnode, into different parts on the basis of some condition, which is nothing but splitting of the root node or subnode into further parts within some condition. Next, branch or subtree formed by splitting the tree node. Branch or subtree, where in this figure we say these are nothing but the branches, right? Where this branch is further divided into this one and this one, right? So this is nothing but branch or subtree. Next, pruning. Pruning is nothing but opposite of splitting, basically removing unwanted branches from the tree. So pruning is nothing but removing the unwanted branches from further. Just like you people have studied about code optimization and code reduction in your compiler, right? Where unnecessary lines of code or variables can be deducted, but the meaning of that particular statement or the meaning of that particular data set will not change, even though we remove the particular uh, branches from the tree or from that particular data set. This is nothing but the pruning. Next, parent or child node. Root node is the parent node. So root node is the parent node, and all the other nodes are branched from it is known as child node. So the root node is the parent node, and all the other nodes which have branches from that one are child nodes. Okay, so this is about the tree, how it looks like, right? The decision tree terminologies where you need to remember, which are going to be coming in our coming problems, right? So one root node, two leaf node, three splitting, four branch or subtree, five pruning, and the sixth one is parent or child node. So guys, do remember this one, where we're going to start some problems tomorrow on this one, where we can have a good problem on the decision tree. Okay. So next, so we are going to talk about an algorithm for this decision tree. In order to implement the decision tree, simply we cannot do that just as we have seen the number of slides of general examples and practical example about the decision tree. Uh, Even though it looks very simple that it is being divided into number of branches, roots, nodes, subnodes, but finally comes here is the algorithm which will function over here in order to divide the data into a data set into a decision tree, and which is going to be called as the CART algorithm. Okay, so we are going to talk about this CART algorithm. in tomorrow's class. Before we're gonna few more slides. So let's first visualize the decision tree. So we need to understand what is this decision tree visually, and what sort of questions need to be asked and when they need to be asked, depending on the queries what we get from this particular decision tree, right? So here we are going to look into an example of this CART algorithm. I am going to have a data set which will talk about, and I need to visualize how we going to visualize which particular parameter we need to consider in order to make as a root node, right? Simply we cannot make something as the root node and say that yeah, I have done and I have built some decision tree for this one. In order to build a decision tree, certainly you need a root node. So in order to have a root node, which particular data set you are going to take or consider to make it as a root node, right? So here we are going to have an example for that one, right? If you look into this example, we have a Outlook as the root node, and we have the two subnodes as humidity and windy, right? And here you have all the S, right? And if the humidity is high and if the humidity is normal, suppose I want to play something, I need to check whether it is humid or it is windy. If it is humid, if it is high humid, I am not going to play anymore. If it is normal, just yes, I am going to play. And windy also the same thing. If it is windy, if it is strong wind, I am not going to play any game. If it is weak windy, then I am going to play game. So what about this S case? I'll explain you in the coming slides about that one. Okay, do remember that. So if you look here, learn about the decision tree. I have given few points. So what is it? Which one among them should you pick first? I have four things: outlook, temperature, humidity, windy, and play. So I have the four different categories what were given here. Outlook, temperature, humid, and windy. So what I should consider as the root, whether I should consider this outlook as the root node, temperature as the root node, humidity as the root node, windy as the root node, depending on because I need to play. Play is the important condition for me, but which one I should take as the root node for that one. So determine the attribute that best classifies the training data. So we need to consider the training data which is going to best classify our this one. Basing on the data, we need to classify the data is been properly been given, and we need to study this entire data set very clearly before selecting that one. But how do we choose the best attribute? In what way we can choose? Or how does a tree decide where to split? Whether the tree decides on itself? No, we need to classify that one. For this we need to consider all these things. Okay, so you have the outlook. We have the category of sunny, overcast, rainy. Okay, if it is sunny, how many no's are there? If it is overcast, whether it is yes or no. If it is rainy, what is that? In the similar way, temperature, hot, cold, mild. These are the subcategories once again. If it is humid, high, normal, these are the two cases. If it is windy, whether it is a false case or the true case. For the false cases, number of no's are there, number of s are there. So we are going to look, and we're going to solve a problem on this one. Okay. So, so these are the four parameters which basically functions important in order to calculate this problem. So we are going to talk about Gini index, chi-square, information gain, and reduction in variance. So we are going to calculate all these four things for any given problem. Okay, one. 2, 3, 4. So what the maximum information we'll get is the information gain. So basing on this information gain itself, we are going to select the group node. Okay. So this is about today's class, guys. If you have any doubts, kindly you can prompt me. Tomorrow we are gonna start with the problem, knowing about these points very well, and about the entropy and the information gain. We're gonna complete this one. If you have any doubts, kindly you can raise your hand, or kindly you can type in the chat bar. I'm ready for that because the session gonna end in another 2 to 3 minutes. So before that, I want to have few questions if you have any. Hope you have understood the things very well. Tomorrow we're going to start with the good set of problems. All of you clear, guys? Kindly let me know if I am fast or slow, or you need more detailed explanation regarding anything, so that I can adjust myself for your frequency. Hope that we have done today's session very well, and thank you very much, all of you.
రుచికి నాశనం చేస్తాము బండి కాలుష్యం ఊది వేడికి పోయి ఆకరించి ఇవన్నీ వచ్చి అంతేగాని అంటారా మీరు తెలియాలి బ్రేక్ ఇచ్చారు అలాడండి బ్రేక్ ఇచ్చి తర్వాత చూస్తుంది అదే మళ్ళీ ఇంకో రాయం
Namkal రెండు లేవు
ఇదే తగ్గుదల కాదు
వచ్చి కలెక్టింగ్ కలెక్షన్ అయిపోతుంది
చేతిలో మానవ రాహం తీసుకునేది casi Javier de la frente అని వాడు కొన్నాడు రామేశ్వరం రాడు టీవీలో స్వామితో వస్తాడు కదా వాడికి
ఒక ముక్కు వస్తే ఆటో
ఇచ్చాడు వాడికి వాడు ప్రదర్శన చేశాడు అన్ని వాడి సిటీ హబ్బులు అంటే ఏంటి ఒక ప్రాంగణం హైటెక్ సిటీ అని సాఫ్ట్వేర్ ఆఫీస్ అని ఒక ప్రాంగణంలో వాడే కడతాడు వాడే తీస్తాడు పని చేస్తాడు వాళ్ళకి అట్లా అలాంటి వాళ్ళు హైదరాబాద్ 5 మంది సీఎం పర్మిషన్ ఇచ్చేట్టు వాళ్ళ దగ్గర వాళ్ళకి వాళ్ళ దగ్గరికి స్వాములు వెళ్తారు. అవకాశం కదా వీళ్ళు కూడా వాళ్ళ దగ్గర డబ్బులు సంస్థానాలు వాడు మఠాలు పెంచుకుంటున్నారు. జరిగేది వాళ్ళ దేశంలో జరిగేది నష్టమైపోయింది. వచ్చేసింది మొబైల్స్ వచ్చి ఇంటర్నెట్ వచ్చి నాశనం బొగ్గు బొగ్గి దీని కంట్రోల్ ఉన్నది కాదు. దీన్ని కూడా ఈ డబ్బులన్నీ ఎవరికైనా ఇవ్వాల్సిన ఇచ్చేస్తుంది. ముందు పిల్లలు మాట్లాడితే వాళ్ళ ఆలోచన వాళ్ళ ఇది మాట్లాడే సలహాలు కంటారు. తెలియదు కదా వాళ్ళకు తెలియదు అట్లా తయారు చేసింది దేశం. ఇవాళ చూడరాదు ఒక్క హాస్పిటల్కి వెళ్ళేందుకు లేదు, అక్కడ తిరిగేందుకు లేదు.
హాస్పిటల్స్ ఓపెన్ చేయొచ్చు.
పని చేశారు.